This is assignment 1, case 2 for a Couette flow. Again, same with the first video. I've gone and done the tedious steps before. I'm going to quickly run through them just to save video space. So first and foremost, I did the geometry. I clicked my XY plane. I went to my sketching. I clicked the line tool, and I drew basically a two-dimensional rectangle like this, which will be my pipe. I then clicked dimensions, general, and then I was able to drag down and out to the side the length and the height, which I set to 10 millimeters as the height and 500 millimeters as the length. And the units can be changed right here in millimeters. After this is completed, I went to concept, surfaces from sketches, I clicked that, and then I highlighted this with the box tool, clicked apply, and then I clicked generate, and that created this solid surface here. Next, I can show you the meshing that I did, which is very important for this. So for the mesh, let me open that up really quick. First, I began with an automatic method, which basically just does a very, very, very brief mesh over the entire figure that over the surface that I created in the geometry section. But that's not enough, so I had to do edge sizing twice. The first edge sizing I did, I had to do 250 divisions, exactly the same as the case 1, between the inlet and the outlet. Which I did here, and it is a hard behavior. I clicked generate, and yes, it created a mesh from the left part to the right part. But we also need a mesh from the top to bottom, which we did with the edge sizing too. We did 400 divisions from top to bottom, and the behavior was hard. We clicked generate, and that made a more defined mesh. But if we wanted a super defined mesh, which with what we have now, you have to use face meshing. And face meshing basically just makes everything a lot more refined for your final answer. I click generate, and then as you can see here, when we zoom in, it's a very, very, very fine mesh, which is exactly what we're looking for. The last part of the mesh section is to just basically label your edges and your boundaries. So I have my inlet, I have my outlet, I have my top, and I have my bottom. And that's all that's to it. So that's all that is for meshing. Next is the setup. So I'm going to go to here. For the models, we're using laminar flow again, just as case 1. The only difference between case 1 and this one is your boundary conditions. Our bottom plate is still going to be stationary. I'll bring that up just to show you really quick. Stationary wall. Because we are in a Couette flow, our top plate is going to be moving. I've made my top plate move at 10 meters per second. Exit out of that really quick. Our outlet is going to be a pressure outlet, pressure of 0, or gauge pressure of 0. Our inlet is a pressure inlet as opposed to a velocity inlet compared to the first one. And again, our gauge pressure is going to be 0 there. So the only way the pressure or the air is going to move is due to the plate, which is going to be at a constant velocity and cause the air to move along the top plate. So that's it for our boundary conditions. Next, we go to our reference values here. Our velocity, as you can see, of the air is 0 meters per second, and our viscosity is going to be 0.0001 kilograms per meters per second squared, or just meters per second. Following that, we need to do an initialization, which I can actually do right here. I'll initialize it. Let that work. Hybrid initialization is done. Then our next thing is to run our calculation with 500 iterations. We calculate this. I did this a little earlier. I believe it went to about 140 iterations, so this should take about 30, 40 seconds. So I'll let that sit there for a second. Slowly but surely getting to our correct iteration. I believe we're about halfway there now. believe we have about 40 more iterations, I believe, for this one. As you can see, our lines are they're starting to decrease starting to decrease towards the end here. Iterations going up still. A lot longer than I thought it was going to take, but we should converge to our answer at 141 iterations. Calculation is complete. We can then move on to our next step. So I'm going to go over to here. I'm going to update our setup, update our solution, and then I'm going to go to the results section, which I will share screens in a moment with you. New share. All right, so I should be sharing the current screen. I'm going to turn this to the z-axis. I'm going to very quickly insert a contour. This is just, I'll just call it velocity, or just call it Couette velocity profile. All right, our location, it's just going to be all along. Our contour is going to occur all along this this figure I've made. We're going to be using variable u, and we're going to do 100 contours, and we're going to apply that. And we should have a nice looking contour. Yep, perfect. That's what I was looking for. All right, so we're going to move this down here, and that actually looks like the correct contour for this specific Couette flow because only the top plate is moving. So we really only expect to see our higher velocities at the top or upper plate, I should say. So let me zoom out of there really quick. All right, so next we have to make a graph of our velocity profiles at our halfway point and our end point. So I'm going to very quickly take off our contour so we can see these lines. We're going to go to location, line. We're going to do 250 millimeter mark. So it's line 250. Okay. This is going to be a location X 0.250. This is in meters, by the way, so I have to convert this from millimeters to meters. And our height is going to be 0.01. Apply, which will put us a line here. We have to do one more line, so we're going to go to Insert, Location, Line. This is going to be line 500 millimeters. Okay. Point 1 is 0.5. Our next point is 0.5, and our height is going to be 0.01. Apply. We get a nice, let me apply that really quick. Apply. Nice little yellow line there. We can put our contour back up. We can go to Insert Chart. We're going to call this Case 2, just for now. All right, so our title, this is going to be Case 2 Couette, C-O-U-E-T-T-E flow. I believe I spelled that correct. If not, I will adjust it after. Okay, so our data series this is going to be 250 millimeters, graphing at the line 250 millimeter mark. Our x-axis is going to be our velocity, and our y-axis is just going to be our y. And we should be able to apply this, and we should get, yep, we got that first line done. So that's at the 250 millimeter mark, and now we have to add one more for the 500 millimeter mark. So we'll go up here, we'll click Add, Series 2, 500 millimeters. This is going to be, again, at our 500 millimeter line we made, and we're going to click Apply. And as you can see here, our velocity profile kind of gets more linear as we go down the length of the pipe, which is what we would expect to see in a Couette flow. So yes, this is my my contour, and this is the, where are we at, chart viewer. This is my velocity profile of the Couette view at 250 millimeters down the pipe and 500 millimeters down the pipe. And that concludes this assignment 1, case 2.